In Wikipedia, there's a very interesting topic which I invite you to read. It's called cognitive biases. And it lists 20 cognitive biases which we Homo sapiens, plains of Africa brains make. You know, we are not rational thinkers. We make all kinds of thinking mistakes, and that's okay. Some of them include relationships are linear, and they're not. Or, as Olve mentioned, local optimization. It's such a common cognitive bias to assume that if I optimize for me or my group, that is best. And the thing about local optimization is it's rarely, if never, done with ill intention. It's done with the best of intention. And that's the kind of the irony of it, because you've got everyone doing their best, and the system is getting worse and worse. This is the irony of local versus systems optimization. But what I get paid to look at, and what I'm interested in looking at, is optimizing the whole rather than the part. And so I'm going to share a story from that point of view. But before I get into the details of this story, something that I want to share that's, I think, really important is that I'm going to be sharing a story from the viewpoint of a particular optimizing goal. And I want to make it clear that that's not a Platonic truth. I'm basically going to be exploring optimization from the point of view of reducing cycle time and increasing flexibility. But those are not necessarily good. There is no good or bad unless we're talking about violating laws. It just boils down to what you want to optimize for. And if you, like, for example, I've worked in the U.S. defense industry in the U.S. I was just with some folks earlier this week here in Norway who work for the Norwegian military unit. And they optimize quite consciously in the United States for secrecy in their organizational designs, at least for product development. If you've never thought about this, another way of saying to optimize for secrecy is to minimize knowledge. Right? I'm not being, sarcastic. That's just another way of describing it. Another way of saying minimizing knowledge is maximizing ignorance. Maximize ignorance is the same thing as secrecy. So they want an organizational design that is maximizing ignorance. And I know how to set up a design for that, an organizational design for that. You probably do too. This is the beauty of local optimization. It's so easy to create an organization like that. And there's nothing wrong with that. But you better be, I claim, clear that that's what you want to do. Because if what you actually want to do, for example, is reduce cycle time and increase flexibility, but you're actually optimized for maximizing ignorance, well, then we're not all lined up. And there we have a problem. So whenever we're talking about systems optimization, to summarize, I suggest that you start with a conversation with your colleagues with this question, and this is especially true for the senior leadership in a company who, it is my opinion, it is their remit primarily to think about fixing the system. That leadership should be especially consciously thinking about what do we want to optimize the organizational design for, and then ask the question, do our choices are consistent with or inconsistent with that conscious choice? Now, I'd like to say that systems optimization is everyone's job. I certainly don't mean to imply it's just for those in senior management, but they tend to have the kinds of levers which are most influential here. Now, I want to pick up this story from the viewpoint of a very common design that I see in many organizations in my world, which is typically large-scale development. So working at a place like Xerox or Ericsson or NSN, Nokia, Siemens Networks, or various other companies that have hundreds, if not 1,000 people working on a single product, one of the common unit structures that I see is called component teams. And I want to explore this a little bit with you so that you understand the implications of this. And just to define my terms, first of all, so these boxes represent architectural components, chunks of, let's say, software. They can also be hardware. And I'm not a complete fantasist. I understand that solving this problem with respect to flexibility on the hardware side is a lot harder. But if we take, for example, just the software side, you can probably appreciate it's going to be a somewhat easier problem to address. So we have an architecture here of components, and let's imagine they're chunks of software. And I want to be clear, there's nothing wrong with having components. That's not what this exploration is about. It's rather that a very common organizational consequence of having components is something that a guy named Conway talked about many years ago, and has then come to be called Conway's Law, although he didn't call it that. And what Conway observed in this paper was that if you make an organizational structure, for example, of 7 groups of people, and you say, okay, you're fixed into 7 groups of people, and that's how it must be. Now, 7 groups of people, I want you to create a compiler. You will get a 7-pass compiler, he observed. And as a corollary, if you fix the architecture, there will be a tendency to then attach people to these architectural units. And his conclusion was that because you get rigidity this way, inflexibility in your organizational design, this is a very dangerous path to go down. But he observed that people fall into this all the time. It's a kind of local optimization. And so from this, you get Conway's Law, which is the organization of people around a particular component that we call a component team. And I want to make sure this is clear. Conway was not recommending this. If you ever hear somebody say, oh, Conway recommended setting up like this, no, not at all. His whole paper was a warning about how dangerous this was. But it was a tendency because of local optimization, cognitive bias. Okay, so we got people attached to components like this. And let's just keep it simple and talk about pure software. These are a bunch of programmers. And we'll come back to why we set up like this later on a little bit more. But I want to explore now a basic question that comes up is, how do requirements get processed through this system? Let's take a requirement F1. Now, if this is a customer requirement, a complete end-to-end requirement, and if every customer requirement is just localized inside of one component, the analysis, the systems analysis that I'm going to make isn't really a problem. The problem comes that typically, not always, but as a kind of a statistical pattern, the requirement cuts through multiple components. And so too, let's consider F2, maybe it cuts through components like this, and so on and so forth. So I'm going to assume that that's a given for the analysis that we're going to explore. If this is our organizational structure into component teams, and if it's true that true end-to-end customer requirements cut across multiple components, I'm going to ask a series of rhetorical questions and then basically answer them in the way they typically get answered in organizations. The first question that gets asked is, or that I'll ask, is who's going to do the complete end-to-end analysis for F1? The UX analysis, the functional requirements analysis, and so forth. Is it going to be this team or this team or this team? Well, of course, it's a kind of chicken and egg problem, and it's not clear which of these teams would do it. Furthermore, as I've set up the story, these are primarily teams of people that we think of whose job title is programmer. And yeah, maybe they could do UX and analysis, but we think of them as programmers, so there's that. And although I've only shown a diagram with 9 components, for example, in a telecommunications product, like at NSN or Ericsson, it's not 9 components, it'll be 609 components. And it's not at all immediate obvious what components are even touched by F1. And so even the question of who would do it, what team would do it, when you're talking about my world of relatively large-scale development, is really difficult to get clear on. And so because of these issues, the common answer to this question of who does the beginning analysis of UX and maybe UI design and functional analysis is some person or group before these groups. It's a logical conclusion. And so then F1 comes to a group of people that we could call doing UX and requirements analysis. Sometimes they go by names such as business analysts or requirements analysis or engineers, systems analysts. The names vary, but it's that kind of stuff. And I want to make it perfectly clear that the introduction of this group is a side effect of, first of all, introducing this constraint into the organizational design, that you have component teams like this. And if people could just put their phones on silent, please. And what do they output? They output what some of these groups euphemistically call deliverables, as though you could actually sell this thing. And some of these groups create the illusion that what they're producing is actually value. With euphemistic phrases, oh, that's a deliverable. No, I'm sorry, it's not. It's a bunch of pieces of paper that you can't sell to anybody. You can't make any money on it at all. And the company has spent time and money making this, and you can't get any return on investment on this. This is not a deliverable. This is waste in lean thinking. Lean thinking in Toyota, lean thinking has a very, we'll say, simple view. It asks the question, can I make money with that? It's a very hard-nosed perspective. And the answer is no. So it's very simple. In lean thinking, if I can't make money with that, it's not value. And it's one of the wastes called work in progress in lean thinking. All work in progress is a form of waste because you can't get any return on investment on it. Okay, let's move on. Another question that we have to ask now is what components are being touched by F1? Again, it looks obvious in this diagram, but if there was no diagram and you've got 600 components and I say, hey, F1, and there's 400 people involved in the product, and then what's the answer to what components are touched? It's not at all so crystal clear. And so in the really large-scale world, it's quite common that somebody has to answer a question that they'll typically answer in some kind of a table or a spreadsheet, where there will be the components and a set of requirements, and then there will be somebody who asks and answers the question to the best of their ability, what components are touched by F1 and by F2, so that we then can organize the work for those component teams. Now, who's going to do that? Is it going to be one of these 3 teams? Well, no, because we have this chicken and egg problem again. So that means we need to introduce another group before this group. And they go by different names in the companies I've worked in. Often in really large scale, they'll be called systems engineers. Sometimes they're called project or feature managers. Sometimes they're called architects. The names change. And they produce some kind of another WIP document. Again, more money has been spent by the company creating this document. You can't sell this and make any money on it, so it's all waste. from the point of view of hard economic thinking, lean thinking. And we have another document that answers that question. Sometimes in this document, or in a variant document, these people also answer another question, which is that there might need to be an interface between these two components so that they can talk to each other. Now, who's going to create this interface? Will it be this team or that team? Well, of course, if they're together in the same room and they're in a collaborative relationship, probably they can work it out somewhat organically. But in the very large scale, and especially if it's multi-site, and if you've got these component teams at different sites, so this is in RTP, this is in Oslo, and so forth, then they have trouble talking to each other. There's kind of like impediments to collaboration and free flow of communication. And by the way, those are just programmers. They couldn't possibly be smart enough to figure out a good interface API. So we need a more intelligent and experienced person called the architect to solve this problem. So then we introduce this other person who not only answers the question of who does what in terms of components, but they might also then define the interfaces between components. But that depends. Now we're ready for the goal of getting these people to do kind of the key work of developing the software. But can we give this document to all of those three teams? No, because this document is for F1 in an end-to-end perspective. So we have to chop it up before we can give it to those three teams. To visualize it, what we need is something like this that we can then give to these component teams. So who's going to do this chopping up activity? Once again, we don't think it'll be any one of these component teams. That doesn't seem logical, and there's a chicken and egg problem again. So we'll introduce somebody else. And this person, the name varies. It's sometimes a project manager or a feature manager or a business analyst or a technical analyst. The names change. And they take these documents, primarily this one here, and then it's not just a matter of putting in a line break at a particular page. It's more complicated than that. They have to think it through and disentangle it and see what parts of the requirements go to what components. And so this person eventually does that and then eventually creates these new documents. Once again, we've got more work in progress here. This is all WIP, intermediate waste. And this component team now receives this document. And when I started working in really large-scale development, I would go to these kinds of component teams and say, "Are you working on customer requirements?" And they would say, "Oh, yes." They can't even see the system anymore. They're in such a narrow view, they actually think that that's a customer requirement rather than a technical task. So they've completely lost sight of the big picture because of how the organization is set up. Now, let's move on. Well, these three teams are going to do the ultimate deliverable work of what you really deliver to the customers, which is creating the code. And so they ultimately create the code. Let's say that's the code. The way I've just drawn this picture could give you the impression that F1 is just flowing through and then poof, all the code comes in here on May 1st, all together. But it's actually not like that. Because what's flowing through the system is not F1, it's F1 through F100 or F50 in reality. And so what really goes on is that a whole bunch of these requirements are pushed through this system. And when I use the word system, I'll mean the organizational system, not the product system. And they also don't just flow through one after the other sequentially. As you can see, the work is starting to get all chopped up and done out of order. So, in fact, if the work is not chopped up, it turns into queues of work packages in front of this group. Or if it doesn't turn into a queue, this group will start multitasking in order to give the appearance of being busy. And as you might know if you've studied systems thinking, being more busy can actually reduce the throughput of the system, not increase it. So we have a queue here, and then we'll have a queue here with more multitasking and batching up. And there will be a queue there. And this team, and this team, and this team will all have queues in front of them. So for example, when I was working in Hangzhou, China years ago, I was with a group that was working on a requirement, let's call it F1. And one of the teams, before we got there and changed the organizational design, one of the teams worked on their requirement 11 months. 11 months before that group started to work on their part of the requirement. 11 months. That's a pretty big delay. And that's the kind of thing that can happen in this system. I'll give you another example of how the system can get suboptimized. A couple of years ago, I was in an investment bank where we were changing the organizational design from this model to another model that we'll explore. And I was fortunate to have a lot of the people in this entire system, it was about 150 people, in one room at the same time, because we were preparing for an organizational redesign. And we got talking about a real requirement that they had to do, and someone threw out the name of this real requirement. And because I've worked a fair bit in investment banking, I had a feel for what the requirement was. I knew something about it, and I had a feel for how much work it would have been, how much actually hands-on or minds-on effort, time on task it would be. And when this person started talking about this requirement, the duration came up of when it would be finished, from the time it came into the door of the bank and from the time it would exit. And it was going to be 5 months cycle time into the bank, out of the bank. 5 months. And we're 150 people, and I knew a fair bit about this requirements, and I was pretty surprised. 5 months. So it came to my mind to ask the people in the room, how many people in the room actually have worked on this requirement or have a plan to be working on this requirement? And a bunch of people held up their hands. Then I asked them to write down on pieces of paper their actual time on task, the real minutes working on that requirement that they had up until that point, and their estimated real time on task, not duration, but time on task, remaining. And for about 5 minutes, they wrote down on paper. I collected all of the papers, and we added it all up, and it came to 7 person days. About 6 person hours a day, something. It was about 40 person hours, if I recall. It was about 40 or 50 person hours. 40 or 50 person hours, 5 months to push it through the system because of the nature of this kind of system. Now, those are extremes, but this is the kind of sub-optimization you can get if you're trying to optimize on reducing cycle time, for example. Well, we got the code in here, but I want to make sure you understand that the code doesn't all fall in on May 1st. Their code might come in on January 20th, and their code might come in on April 17th. And so another problem that comes up now is the integration of the code problem. And in very traditional organizations, the way that this is then resolved is to delay the integration. Maybe they work on different branches, for example, or they just don't check it in. And then eventually someone's got to stick it all together and make it work together. Who's going to do that? Is it going to be that team, or that team? Well, in traditional organization, once again, that's not clear. So we introduce another role. What's that role called? No, we're not testing yet.
Integrator.
The integration manager. And so then we get an integration manager who makes it her or his job to try to stick it all together. Someone mentioned testers. We got to test this thing end to end. Who's going to do that? Is it going to be one of these groups?
All.
No. What's that?
All of them.
Well, that's what you would like. But what the answer that I'll share with you is the one that I usually see. And the answer that you usually see as a kind of a consequence of the belief of how the system is set up is something different. What do people usually believe that you should do?
Solutions test.
You need some kind of a solutions test or end-to-end system test at the end that you add after all of these. I'm not saying this is a good design. What I'm just sharing is the story of how it's usually set up as a consequence of all of this. And then they do the end-to-end testing. Well, we need even more people for this system. Because of how the work has been chopped up, there's a chance that someone can drop the ball on F1 as it flows through the system, the whole picture of F1. So there's a chance that no one's keeping an eye on it end to end. So how do we fix that problem? What do we introduce? What other role do we introduce? A project manager. So now we need what in some of my customers is called a feature manager. In really large scale, you call them feature managers, and they keep track of a subset of the features. Or sometimes it's a project manager, and they work end to end. So, as a rhetorical question, what do we have here? We have what I call a sequential life cycle. It's a life cycle in which there's a sequential flow this way through to this way. And the feedback loops are, they're not structurally in place, they're only informally in place. The organizational design is not set up for feedback loops and learning and evolution. It's set up for essentially a sequential pass. Of course, feedback loops happen, but they happen by kind of fighting the way the system is set up. I mean, feedback is the problem, not the way the system is actually fundamentally designed. And so you've got a system with weak feedback loops, with queues in front of all of these single specialist groups, with increased multitasking, and the amount of one of the other wastes is called the waste of handoff. The amount of handoff waste is massive because, as you can see, between all of these groups, there's handoff after handoff after handoff. So the amount of information scatter, misunderstanding, and so forth, the opportunities for this are massive. And how transparent is this system? How well can you actually see what's going on? It's very difficult because everyone is busy doing their own local thing. And there's high levels of work in progress. So the ability to see the whole and ask what is the whole end-to-end system is very difficult. So that's kind of the picture of the system. And we know, if you've studied, for example, software engineering research, that sequential lifecycle systems are associated with the most cost overruns and the most schedule overruns of any organizational model. About the only way that you could make this worse in terms of increasing schedule overruns and cost overruns is instead of having component teams, you have component people. So you can kind of maximize the pain by saying, that's your component, and that's your component. And you can really make a mess of things. If what you're trying to do is optimize to reduce cycle time. But now I want to explore this from a slightly different perspective. Suppose that we have a list of customer requirements. And suppose that what we would like to do is sort these by some good definition of customer value. Now, I hesitate to use the word customer value because when you say it like that, it sounds like that's some clear and obvious thing which is easy to measure. And in fact, customer value is a composite concept, which in my view is composed of multiple things, which could be total life cycle profit over a 5-year analysis, or strategic customer alliances, or capturing market share, or reducing some risk, or alignment with a corporate strategic intention. There's a lot of ways you can combine the notion of what is the most valuable, and it's not as simple as just value. But let's take it as a given that somehow we could sort these things by what we consider value. Now, I claim that most of the companies I work with would like to be able to put through the system things according to highest customer value. And this is a very lean perspective, which is that you would like the system to be optimized around doing the things of highest customer value. And that's not necessarily a required optimization, but let's say that's what our goal is. Let's consider this system from the viewpoint of wanting to achieve that goal. So let's suppose that this group here is called C9. And let's consider the components that are touched by these requirements. So suppose this one, for example, is C2 and C4, C3 and C5, and so on. You get the idea. And the first one that, let's call it in the order of value, is 55. The first one that actually touches upon component C9 is requirement in the priority order 59. So I hope you can see the problem right away. We can't, in this organizational design, maybe can't is too strong a word, but it's extremely unlikely in this organizational design that we're going to wait until we work through 54 before we give some work to component team C9. It's not like the case that, okay, guys, you just go skiing for the next 6 months while we do the higher priority things. So instead, what do? We instead have to change the order of the list. And we reorder the list. Here's the key point. We must is too strong the word, we desire, because we're optimizing to keep people busy. Key point. We're optimizing the system to keep people busy. We reorder the list so that people are busy. What can we give next to component team C9 so that they can be busy? And so therefore, in this organizational design, this is a key point, with single function teams, not only single function programming teams, but single function analysis and architecture and so forth teams, you're always optimizing for busyness rather than optimizing for higher customer value. So now we have a sub-optimization from the point of view of highest customer value. It gets even better. Because, okay, so we're trying to keep C9 busy, but in this model it's actually hard to really keep them busy all the time. So there'll be sort of times where they're not really quite so busy. But they're not allowed to just go skiing for 7 hours a day. They have to appear busy. So what does the group do? I'll pick on C9. what does the group do to appear busy?
Great work.
They create work. So they make so-called customer requirements. Or if they can't make so-called customer requirements, well, everybody needs another logging framework. Or whatever. So this group then ends up, if you think of it in terms of the resources of the company not only are being applied suboptimally from the point of view of customer value, but are being applied by makeup work locally in order to appear busy. And what is the cheapest software system to maintain in terms of number of lines of code? 0. And every line that you go up is worse. Likewise with defects. By the way, as a tangent, I've done some work in the U.S. nuclear power industry. And in the power industry, they're required to do code reviews. And the one and only one question that you ask in a nuclear power code review is, how can we reduce the number of lines of code? It's a very interesting question, because they're very sensitive to the fact that every line of code is a potential disaster. I mean, without obfuscation. So, this group is pumping out code. So the code in your system is growing as well. And if you're a senior manager paying for the system, I hope you can see that's not a good thing. You're not optimizing your money on the things that will give you the most value. Not only that, I repeat, this has a care and feeding cost, right? Now, it gets even better. Suppose that for release number 1, a big release over, let's say, a 12-month period, that the number of people in the different component teams was more or less balanced in order to get the work done through the first release. But in the second release, release number 2, the area where the major, most important requirements are is here and not here. And so in the second release, the management team looks at the list and they go, oh my God, we've got a lot of important work to do that touches these components, and I don't think we've got enough developers there to solve the problem. Now, I'm not suggesting that we actually add more people, but a typical response to this problem is to add more people. So given that that's the case, where are these people going to come from? Well, you might say, oh, well, these people over here, because these components aren't so important in this release, why don't they move over here? But every one of these components has attached to it a manager. Mm-hmm. And now we come to something called Larman's laws of organizational behavior. Law number 1. Organizations are implicitly optimized to maintain the status quo for managers and single specialists. Organizations are implicitly optimized to maintain the status quo for managers and single specialists. Back in the 90s, I worked at a company in the US called Sprint, a telecom operator, mobile telecom operator, and they had a policy that to move from being a senior project manager to a program manager, you had to have first led a 100-person project. Can you guess how many 100-person projects there were in Sprint? So how does this person's status grow? It's, I guarantee you, not by cannibalizing their team. So this person goes, no bloody way are you going to take my people. They're doing really important work making a new logging framework. And so forth. So there's this organizational resistance to move the people because of the classic management status game. Furthermore, and we'll come back to this a little bit later on, Another excuse that the managers make so that we don't shift the people is that, our component is really complicated. It couldn't possibly be the case that this programmer over here could work on that code over there. It's like, your head would explode. Not possible. So we'll come back to that question anyways. But in any event, that kind of stuff goes on. So then, what do? They hire more people. And of course, I'm not assuming a situation like where there's a strong hiring freeze, because there'll be situations which you will get over this inertia and move people. But I'm talking about in a kind of typical case. The money's flowing. Let's add more people. Okay, release number 2. And of course, and there might be actually more programmers here than you actually need because you're not optimizing for customer value. But all of these boys and girls have to be busy 7 or 8 hours a day. So what do they pump out? Code. So you're optimizing to pump out code rather than customer value. And so the number of lines of code grows locally, even if it's actually not aligned with customer value, which makes the code base grow here, and then that leads to a positive feedback loop to believe that you need even more people here. Now let's come to release number 3. In release number 3, let's say these are the components where all of the most important customer requirements are, and the management feels for some reason that we need more people here. Oh, by the way, another constraint on this is if these components are at different sites, because then the willingness to shift people across the components/sites is even more intransigent. And so we come to the 3rd release, and this is where we need more people, and the story repeats, and so then we add more people here. And so then we end up having this positive feedback loop where we've got this ever-growing organization which is starting to gaze at its own navel and create larger and larger components not really aligned with customer value. It gets even better. Well, at least, you say to me, Craig, at least the code in this component is really great. Because these programmers have at least been staring at these 20,000 lines of code for the last 4 years, so at least we get that. And I'll actually grant you that there are companies where that is true. And I would say, for example, that your company is one of them. But I work across a lot of companies, and I work as a programmer, and so I see a lot of this code, and I work with a lot of this code. I'm not just in the boardroom, I'm in the workroom. And I do pair programming and mob programming, so I really have a feel for this code across a lot of companies. And the typical case is that I'll go into one of these companies, I might be doing some pair programming with some of these developers, and they'll often sit down when we first get together with me, and one of them will say some kind of variation because they know that I like clean code and nice design and so forth. The first comment will be when we open up the IDE and start looking at the code is, Craig, I know it looks messy, but we understand it. So here's the funny dynamic. So let's take it in a steady state. The code's in some state. And they need to hire someone, and it's some fresher out of university. And the fresher comes in, doesn't really know what's going on in terms of business dynamics and systems dynamics. And they're introduced to all of this code, and they go, oh my God, it looks really complicated. And these people say, oh yeah, it's inherently really complicated. You have no idea. And this guy says, are you sure? Oh yeah, it's really complicated. We'll give you simple tasks to work on it for a while. And here's the thing. If you just keep looking at it, then over 6 or 9 months, it'll start to make sense to you. So then what happens to this person is that instead of their first initial reaction is, God, this is a mess, why don't we clean it up? They're told to just look at it because it has to be that way. And then after 9 months they go, oh yeah, it's perfectly clear to me. It's like they just swallowed the blue pill. and now all the fog clears and the 20,000 lines of obfuscated code makes perfect sense. And they can no longer even smell the garbage that they're sitting on. It just is perfectly clear to them. And then how do they grow as a programmer? How do they learn to make great, clean code? Is it by sitting with the same other 4 programmers for the next 4 years, all telling each other that this is the way it needs to be, and learning virtually nothing because you're just with the same 4 people all the time and staring at the same 20,000 lines of code? I'd like to suggest that that's not a very powerful way to learn how to make great and clean code. The way that typically people learn how to make great, clean code is by being exposed to different developers with different perspectives and different code bases. Most of you who work as developers know this. And this absence of learning or feedback or injection of new ideas then leads to a kind of steady state where all of the code, it will have a kind of architectural integrity at the boundaries. I'm not saying it doesn't work or it's buggy. I'm just saying that if you go try to work with one of these things, you'll go, huh? Inside, it'll seem like there'll be lots of dark corners that you don't really want to have to know about. So there's no forcing function to really make clean code. So why do we have this organizational model? Coming back to one of my opening comments, it boils down to, it seems to me, a couple of beliefs and cognitive biases. One is this Homo sapien cognitive bias of local optimization. It just somehow feels or seems best that if these programmers just worked on those lines of code, that will be best. It feels that way. And this is very much a local optimization. Because, of course, when you stand back and do a systems analysis, it's not best unless you're trying to optimize for ignorance. Another reason that I think the systems get set up this way is the, what to my mind, somewhat strange belief that a developer couldn't work on code that was somewhat new to them. Which is always kind of funny because, well, that person started to do it. Like, I'll often hear variations of this story when I come into groups working with component teams. Oh no, we couldn't possibly go to another model because people couldn't possibly learn another component. And then I'll ask a person then on the team, okay, so, well, you joined the team at one time, didn't you? Yeah. How long before you started to work on the component? Oh, it was at least a couple of weeks. So there's, you have to kind of like peel back their assumptions before you realize that it's kind of thin. And another reason why there's this belief that they need to be in component teams is related to the kind of messy, obfuscated code that gets created. It creates this self-fulfilling prophecy that if we've got difficult to understand code, then of course we need programmers who only work on that code. And then again, you've got this positive feedback loop. So that's about all I wanted to summarize for the dynamics of component teams. I'm going to take your question in just a minute. But before I take your question, I want to share with you an alternate model. And this is the model that I usually suggest to groups, and there are situations where it's not appropriate. And these are called feature teams. But before I define feature teams, I want to make it clear that I'm not suggesting a false dichotomy. This is another, by the way, another dichotomy, another kind of cognitive bias or thinking mistake. The belief that there's only two choices. for some reason, computer people are very binary. And they think in, like, oh, okay, Craig, your choices are component teams or feature teams. It's like that old programmer joke. You know this one? A programmer walks into a bar, goes up to the bartender, orders a triple shot of whiskey, really happy. The bartender asks him, well, how come you're so happy? And the guy says, oh, I'm celebrating. We've just had a baby. And the bartender says, is it a boy or a girl? And the programmer says, true. Programmers will get that joke. So it's not like it's just has to be just feature teams or just component teams. We can move beyond that false dichotomy and exploit patterns around the cases where we want to kind of optimize for reducing cycle time and increasing flexibility, where there's a lot of change and a real need for reducing cycle time. For example, we could have the majority of the organization composed of feature teams, and a small number of cases where there's extremely specialized knowledge. We need 3 PhDs with in audio analysis or visual analysis to work on this component because it's a very complicated math problem. But the number of times that people write code that has to cut through that component is quite low statistically. So we could live with the cost of a component team there in the handoff because it's not going to create, in terms of the patterns, statistical patterns that work through the system, actually that big a deal. So don't assume that I'm applying a false dichotomy or one or the other. But to summarize, what a feature team means is that it's a cross-component, cross-functional team of T-shaped workers. So it's not just cross-component and cross-functional. It's not just that we eliminate this organizational design and take all of these people and reform them into cross-component teams and cross-functional teams. It's not only that, although that's a part of it. Another part of it is that each person is a T-shaped worker. Because even if we had a cross-functional team, but one person on the team was only the UX person, and one person on the team was only the test person, and one person on the team was only the component 3 person, and so forth, you'll have exactly the same dynamics that I've described here, but at a smaller scale. And so we don't really optimize the system. We want to actually break this constraint as deeply as possible. And so by making the teams more multi-skilled, we reduce kind of the first order constraint, and by making the individuals, making is the wrong word, by allowing people to learn secondary and tertiary skills so that they become multi-skilled, we then reduce the second order constraint, and then the system is optimized for reducing end-to-end cycle time. Because then you can give F1 to this team, and they can do the UX, the functional analysis, the architecture, the development, the integration, the end-to-end testing, soup to nuts with a significantly reduced total cycle time. And there's more flexibility in this system because now you can order the list of requirements by customer value, and you can give them to teams, because now the organizational system is set up to support going to the highest value work rather than keeping people busy. Thank you for your time.
Thank you very much.